Okay, we are back with part 2 in this video series, and I figured out the error. The error is, in fact, when I wrote down the document, there was a straight-up typo. That plus 1, go back to the beginning problem, was originally a plus 3. That should be a 3. This should be a 3. And now I'm happy. I wind up with the thing that I did need to get. So it did walk out correctly. Excellent, and that's exactly the type of thing that chances are you would have corrected for me had this been an in-person thing. So that's the idea of polynomial division. What I called it there was ad hoc polynomial division because I didn't have an algorithm in mind. I just tried to walk out the biggest coefficient first and went from there. And that's exactly what polynomial long division does. So polynomial long division attempts to find the biggest coefficient, then figures out the second biggest coefficient, the third biggest coefficient, and just keeps going down until it stops. So let's do the exact same process, but let's introduce the language of long division to do it. So let's try to compute the same quotient, and I'll do the same thing. So let's try to compute x to the fourth plus 2x cubed plus 4x squared plus 2x plus 3 all over x squared plus 1. First thing we think about is what's the biggest term we see? What do I need to multiply this x squared by to get this x to the fourth? And well, you know the answer. It's x squared. So you need to multiply the leading term, so that's the x squared in the x squared plus 1 by x squared in order to get the leading term of this. So what do? You write down an x squared on the top, just like you would in the result of division. So you can think of that as being like the initial guess for what long division, the result of long division is. So just like how if you tried to divide, I don't know, 3 into 72, your first guess would be, well, 3 goes into 7 2 times with some remainder, so this thing should be about 20. And then so the first guess would be 2 and you would revise the guess. Same thing. The first guess is it's x squared. I know that it's going to be wrong, but let's do the subtraction to see how wrong it is. So to see how wrong it is, you take the x squared, you multiply it by the thing right there, you put that there with a minus sign next to it, and you do the subtraction. So writing that down, so doing the multiplication first, x squared times x squared is x to the fourth. X squared times 1 is x squared. I'll keep the 0x cubed because I'm going to try to do the subtraction column-wise. Distribute the minus sign. X to the fourth minus x to the fourth is 0x to the fourth. I knew that this would be a 0, that's why I picked x squared to be there. 2x cubed minus 0x cubed is 2x cubed, 4x squared minus x squared is 3x squared. So you'll remember in the step while we were doing the ad hoc thing, where we subtracted 4x squared, we subtracted x squared from 4x squared, we got 3x squared. That's exactly the same 3x squared. So next step, I now need to figure out how many times x plus 1 squared goes into this. So let's keep on going. What do I need to multiply x squared by to get the leading term of 2x cubed? Well, it's 2x. I'll put a 2x there. And now I need to subtract this from the result. That's 2x times x squared plus 1. 2x times x squared is 2x cubed. 2x times 1 is 2x. Distribute the minus sign and introduce the 0 term so you can subtract column-wise. 2x cubed minus 2x cubed is 0x cubed. That's what I knew would be there. 3x squared minus 0x squared is 3x squared. 2x minus 2x is 0x. I'm left with 3x squared plus 3. So now, what's left? I need to figure out how many times x squared plus 1 goes into this. So what do I need to multiply x squared to get 3x squared? Well, it's 3. So the next term is 3. Now I multiply 3 by x squared plus 1. There's minus 3 times x squared plus 1. We do the subtraction. 3x squared minus 3x squared is 0. 0x minus 0x is 0. 3 minus 3 is 0. So now that I'm down to 0, I know that the result of division is exact. this was like the thing I was calling an error term in the guess we have so far. So we have no error, and the guess is in fact just correct. So x to the fourth plus 2x cubed plus 4x squared plus 2x plus 3 all over x squared plus 1 is equal to x squared plus 2x plus 3. And you'll notice that was a lot of writing. It looked like I didn't actually save much space. It took me about 2 pages to do the long division, and it took me a page and some change to do the ad hoc division. The advantage of this is we can now, we don't need to write a new column for each step. Let's do this division. Let's determine how many times x squared plus 2x plus 3 goes into x to the fourth plus 4x cubed plus 2x squared plus x minus 2. So that means I need to compute this long division. X squared plus 2x plus 3. I need to figure out how many times that goes into x to the fourth plus 4x cubed plus 2x squared plus x minus 2. So let's go ahead and begin. So at each stage you look at the leading terms. X squared, x to the fourth. What do I need to multiply x squared by to get x to the fourth? Well, I need to multiply it by x squared. Next, what do? I multiply this x squared by that polynomial and I subtract it. So x squared times x squared is x to the fourth, but I need to subtract it, so minus x to the fourth. X squared times 2x is 2x cubed, I need to subtract it. X squared times 3 is 3x squared, I need to subtract it. Do that subtraction. 0, 4 minus 2 is 2 cubed. 2 minus 3 is minus 1 x squared. Alright, that's progress. Now, last time I carried these terms down, so I'll continue to carry these terms down, plus x minus 2. So next, what do I need to multiply x squared by to get this leading term, 2x cubed? And I think I'll switch to another color to illustrate that this is a new step in the algorithm. X squared times 2x is 2x cubed, so I need to multiply 2x by this and subtract the result. 2x times x squared is 2x cubed, so I'll subtract it. 2x times 2x is 4x squared, and I need to subtract it. 2x times 3 is 6x, and I need to subtract it. Do the subtraction. 0 minus 5x squared. X minus 6x is minus 5x. Minus 2. Alright, cool. I may wind up revising this somewhat. So let's keep on going. X squared times new steps, so new color. X squared times negative 5 is 5x squared, so I need to multiply x squared by negative 5 and subtract the result. Minus 5 times x squared is minus 5x squared, but then I need to subtract the result. So that'll be plus 5x squared. Minus 5 times 2 is minus 10, plus 10x. Minus 5 times 3 is 15, plus 15. Minus 5 plus 10, 5x. Minus 2 plus 15 plus 13. So here's an issue we have which this example wasn't intended to have. This thing is not equal to 0. So we encode that by saying this has a remainder of 5x plus 13. So how do you interpret this result? Well, here's what this means. So x to the fourth plus 4x cubed plus 2x squared plus x minus 2 all over x squared plus 2x plus 3 is equal to x squared plus 2x minus 5, and now we need to interpret that remainder term, plus 5x plus 13 over x squared plus 2x plus 3. So there's this extra remainder term, just like how when you divide fractions into each other, sometimes they don't divide evenly into each other. Sometimes there's a remainder term. Here's an example where there's a remainder term. Cool. So, one thing one could do to double check is multiply this out. So I'm going to add some space down here because this was an interesting result. Let's double check. So I need to multiply x squared plus 2x plus 3 by x squared plus 2x minus 5 multiplied by, plus 5x plus 13 all over x squared plus 2x plus 3. So let's multiply that out. So I think what I'll do is multiplication distributes over addition. So I'll write the intermediate step where I'll multiply all of that by this, all of that by this, all of that by this, all of that by this. So doing that, I have enough space. There's x squared plus 2x plus 3 times x squared plus x squared plus 2x plus 3 times 2x plus x squared times 2x plus 2x plus 3 times negative 5 plus x squared plus 2x plus 3 times 5x plus 13 all over x squared plus 2x plus 3. And here's the thing to observe. If you multiply a thing and then divide by the thing, those two things will cancel. So that last term is just 5x plus 13. Got a little bit illegible there, did it? 5x plus 13. Alright, so now let's distribute. Let's expand this out. X to the 4th, x squared times 2x plus 2x cubed plus 3x squared plus 2x times x squared plus 2x cubed plus 4x squared plus 6x plus, that's a negative, so there's going to be some subtraction, minus 5x squared minus 10x minus 15 plus 5x plus 13. And now I guess we have to combine a bunch of like terms. So there's only one x to the 4th term. Let's find all of the x cubed terms. There's an x cubed, there's an x cubed, plus 4x cubed. Let's find all the x squared terms. There's a 3x squared, there's a 4x squared, there's a minus 5x squared. 3 plus 4 is 7, minus 5 is 2, plus 2x squared. Green seems like a good next color. Plus 6x minus 10x plus 5x. Let's see, 6 plus 5 is 11, minus 10 is 1. Six plus 5 is 11, minus 10 is 1. Plus x, and now constant term. Minus 15x plus 13 is minus 2. Nice. So let's see if that agrees with what it was supposed to be. There's the result of multiplication. The result of multiplication should be the thing we see in that numerator. And let's see, x to the 4th, x to the 4th, plus 4x cubed, plus 2x squared, plus x minus 2. Yeah, it checks out. Groovy. Alright, so I think that will complete this second recording. The final thing that I'll do, so theoretically there was going to be an example with a remainder term, but we just saw an example with a remainder term. So maybe I won't go through that. The third and final recording will be the abbreviated thing you can do sometimes, which is called synthetic division. And I'll summarize this down here. And that will be in a third video that will be posted, well, when the rest of these are probably. Great. See you in class.